Hi guys, this is for 2. So for 2 is about increasing and decreasing functions. So you're going to figure out what intervals that the function is increasing and decreasing through, and then that will help you find any extremas. Okay, so this procedure is very straightforward, and it's basically the exact same steps. We're going to follow through these 3 examples. You're going to start with finding the domain restrictions. Okay, and then once you list the domain restrictions, you're going to find your critical values by finding the derivative, setting it equal to 0, and then finding any value that makes that derivative undefined. And then we will do a number line test. So we'll figure out what sign it is between each interval. And then once we have done that, that'll tell us where the function is increasing and decreasing, and then also where we have maxes and mins. Okay, so for starters, for question number 1, is there a domain restriction? Okay, so there is not a domain restriction. There's no value that makes the denominator 0. So we have nothing to worry about there. So I'm going to go straight into finding the derivative. So to find the derivative of this piece, I'm going to do the chain rule. So I have 2/3 x squared minus 9 to the negative 1/3, and then times the inside, so times the derivative of the inside is 2x. So I can go ahead and multiply the top pieces to give me 4x, and then on the bottom I have 3, and then that quantity is going to move downstairs and become positive. Okay, so critical values are any value that makes the denominator 0 on my derivative, and then anything that makes the derivative 0. So I have immediately I have 2 values that make this denominator 0, which are 3 and negative 3. And then also if I set this function equal to 0, I would multiply this bottom piece to the other side, which is 0, and I end up with 0 is equal to 4x. So I can quickly find my critical values at 0, 3, and negative 3. Okay, so once I have those critical values, I'm going to do a number line test. And the values that I'm going to use for this, or the test I'm going to use, is going to be back at the derivative. Okay, so I'm using this to do my interval test. So if I pick a value that's less than negative 3, let's call it negative 4, and plug it in, that would give me 4 squared, which is 16, and 16 minus 9 is, well, let's just go with a positive number. So we get a positive number to the 1/3 power, which is still positive, and a positive times 3 is a positive. On the top, if I plug in negative 4, I would get a negative, so I'd get a negative over a positive, which would make a negative. Okay, if I plug in a number in between negative 3 and 0, if I choose, let's say, negative 1, at negative 1, I would plug in here, so it'd be 1 squared, so 1 minus 9 is going to be negative, so I'm left with a negative on the bottom, and then I have a negative on the top, so a negative over negative makes a positive. Okay, if I plug in positive 1, I would get 1 minus 9, which is negative, negative on the bottom. If I plug in a positive upstairs, positive 1, so I get 4 times 1, 1, that would be positive. So I'd get a positive over a negative, which makes a negative. And then in my last interval, if I plug 4 in, I would have 4 squared is 16. 16 minus 9 makes it a positive number. Positive to the 1/3 is still positive, so I get positive on the bottom, and I would get a positive on the top, so I'd get a positive over a positive. Okay, so once I get to this point, you can kind of start imagining the function. Remember that these intervals are giving me the slope of my function. Okay, so if I have a negative slope, then I know that this function is going down. Positive slope would be up, negative going down, and positive going up. So this is a very rough sketch of generally what this function looks like. It kind of looks like a W. Okay, so I can find all my intervals that way. I can say that this function is increasing between negative 3 and 0, as well as 3 to infinity. And notice that I'm not including the values 3 or 0 because remember that the derivative at those spots are 0, so we don't want to include the numbers. It decreases from negative infinity to negative 3 and from 0 to 3. Okay, so then for maxes and mins, you can use this little idea of what this function looks like. You can say the max looks right here, at the x value of 0. So to find its corresponding y value, what I need to do is go back to the original function to find its corresponding y value. So if I plug 0 in, I would have 0 minus 9, which is negative 9. Negative 9 squared is 81, and so I have the cube root of 81 as my y value. Okay, for my min, I actually have two minimum values. I have here a negative 3 and a positive 3. So if I plug negative 3 into my original, that would be 3 squared is 9, 9 minus 9 is 0, so I would get 0 for that corresponding y value. And again, now if I plug 3 in, I get the same value for my y. So those are all of the pieces that we are going to be finding on these questions. So not extremely hard, but maybe a little bit tedious. For question number 2, okay, so again, the first thing I'm going to do is I'm going to start with any domain restriction. So I immediately see there's an x in the bottom, so we know that x cannot be 0, so that's going to be a critical value. Then if I take its derivative, I have ho-de hi minus hi-de ho, so I'm going to do quotient rule. So 4x cubed minus the whole, or excuse me, the hi over the whole derivative, all over the whole squared. Okay, so I will simplify that. Let's see, we got 3x times 4x cubed, that makes 12x to the 4th. I'm going to distribute a negative 3 through this quantity, so I get negative 3x to the 4th minus 9. On the bottom, I'm going to go ahead and square both pieces in the parentheses, so that will give me 9x squared. I do have some like terms. I have 12 minus 3 for my x to the 4th, so that will make 9 of those. Okay, so for critical values here, I do have 0 again as a critical value. I did list it previously, so I don't have to say it again. Now if I set this equal to 0, I can probably do that in our heads. The top is just going to be set equal to 0 because the bottom goes away when it's set equal to 0. You add 9, divide by 9, so you get 9 over 9, which is 1, and then to get rid of the 4th, you would do the 4th root of 9, or excuse me, 4th root of 1. So you end up with plus or minus 1, and then we will include our critical value of 0. So we got 0, negative 1, positive 1, whoops. Okay, so again, I'm going to be using this piece to plug in my interval signs. So between negative infinity and negative 1, I'm going to use negative 2. So if I plug in a negative 2, I'm going to get positive over positive. If I plug in 1/2, let's say in between this interval, 1/2 to the 4th is going to be, let's see, 1/16, so something smaller than 9. So something smaller than 9 minus 9 is going to be a negative. So we're going to get a negative over a positive. That one. The same scenario is going to play out if I plug in a positive 1/2. So we're going to get a negative, and if I plug in 2, I'm going to get a positive over a positive. Okay, so remember, if I go back to my original, this is restriction at 0. What's happening with the graph? Remember, if I have an x in the bottom, it's going to create a vertical asymptote. So you can kind of imagine here we've got this vertical asymptote at 0. So the function starts by increasing and then decreasing, and then over here it starts by decreasing and increasing. So our intervals increasing from negative infinity to negative 1, and from 1, oh, that should have been positive, excuse me, positive 1 to infinity, decreasing from negative 1 to 0, and also from 0 to 1. Notice I do have to state that separately because it's divided by that asymptote. For my max, I see my max here at negative 1. So negative 1, remember I have to go back to my original to get that corresponding y value. So if I go back to here, I get negative 1 to the 4th is 1, 1 plus 3 is 4, so I have 4 over negative 3, so negative 4/3. For my min, that's going to be at the bottom here at 1. And if I plug 1 in, I get 1 to the 4th is 1, 1 plus 3. So I get 4, 4 over 3, so positive 4/3 for that max. Nice. All right, so the last question, number 3. This one's kind of an interesting case, so I want to definitely go through it. First of all, I have no domain restriction, so I'm going to immediately go straight to finding its derivative. So derivative is going to be 3x squared minus 6x plus 3. And then to find my critical value, I'm going to set that equal to 0. I'm going to go ahead and pull out a 3 there because I immediately notice all pieces are divisible by 3. So I have x squared minus 2x plus 1. And then I can divide by that 3. So if I divide by 3, that's going to go away. I have 0 is equal to, and this can be factored to x minus 1 squared. So I get a single critical value at x is equal to positive 1. So on my number line, I'm going to use 1, okay, and I'm going to use this piece right here to do my sign test. If I plug in 0, 0 minus 1 is negative 1, negative 1 squared is positive. And if I plug in 2, I get 2 minus 1, that's 1, 1 squared is positive. So for this one, this is very interesting. I have 2 intervals where the function is still increasing. So what is happening on this graph? Remember that we have an x cubed. Okay, so this looks like a cubic function, a John Travolta. So it goes up, he does his little wiggle, and then continues up. So what's happening at the x value of 1 right here, there's a quick instant where this horizontal slope exists, but it just keeps increasing after that. Okay, so interesting in the fact that this function is increasing from negative infinity to positive infinity, always increasing. So therefore, when the decreasing interval would be none. Okay, for a maximum, there is no max. Both max and min do not exist because they go to infinity and negative infinity. So I'm going to say no max or min. Okay, so that's kind of a special scenario. All right, so that should get you through for 1, or excuse me, for 2.